quadrilaterals, and we are going to extensively study the properties of quadrilaterals. And a quadrilateral is any figure that has four sides. A four-sided figure, any four-sided figure is called a quadrilateral. There are many special types of quadrilaterals, including parallelograms, rectangles, squares. I'll go ahead and plug my microphone in. Squares and kites. Yes, that is a shape. I know it's something you fly in the sky, but a kite is a quadrilateral and it looks like a kite. Okay? We will begin by first studying a very broad category known as the trapezoid. And a trapezoid is any quadrilateral with at least one pair of parallel sides. Let's have that minimum. One pair of parallel sides. This means it could have either one pair or two pairs. Some properties of trapezoids. There's two types of trapezoid. That's just a regular everyday trapezoid. Nothing special about it. The bases are parallel. And I like to think the bases are the top and the bottom of the trapezoid. Those are the bases. It has two bases, the top and the bottom. The legs are the sides that aren't parallel to each other. We call those the legs. Right? So AB is going to be parallel to BC. There's one pair of parallel sides, therefore it's a trapezoid. Yeah, you can lower it. Yeah, go for it. You can't see. Another important property of trapezoids is that the consecutive angles are supplementary, meaning consecutive, the angles that are on top of each other. So in this diagram, angle A and angle D are supplementary, which means they add to what? 180. Angle B and angle C are also going to add to 180. They're consecutive. I think they are on top of one another. Here's why. We just said the top and the bottom, the bases are parallel to each other. So if we extend those sides to get a better visual, I extend the top, I extend the bottom, they're parallel to each other. The sides are acting as transversals. So this side AB is acting as a transversal. Well, what type of angles are angle A and angle D? They're both inside and on the same side of that transversal. Right? Same side interior. And what do we know about same side interior angles? They're supplementary. That's why that's true. Here, again, the yellow lines are still parallel. BC is acting as a transversal. So that would make angle B and angle D also same side interior angles, which means they add to 180. That's why. So the angles on top of one another in a trapezoid, the consecutive angles, will always add to 180 degrees because they're same side interior angles. There's another type of trapezoid. It's called an isosceles trapezoid. It's a special type of trapezoid. It has all the properties of a regular trapezoid. So the bases are still parallel. So AD and BC are our bases. It's the top and the bottom. Those are parallel to each other. That's true because it's a trapezoid. The consecutive angles are supplementary. If you look at the second diagram, what are our consecutive angles? The angles on top of one another. What's our first set of consecutive angles? A and B. So angle A plus angle B is going to equal 180. What's our other set of consecutive angles? D and C. So angle D plus angle C is also going to equal 180. But what's special about an isosceles triangle, and why it's called an isosceles triangle, think about triangle. Trapezoid. Think about an isosceles triangle. What's special about an isosceles triangle? Triangle. It's the same. So what do you think about an isosceles trapezoid? How many two sides are going to be the same? And specifically, the legs. And again, the legs are the sides that aren't parallel to each other. So AB and DC are going to be congruent. AB and DC are going to be congruent. So because it's isosceles, because those two legs are congruent, those lower base angles are going to be congruent to each other. Same idea with an isosceles triangle. That means angle B is going to be congruent to angle C. The upper base angles are also going to be congruent to each other. So that means angle A is congruent to angle D. That's also true. And finally, probably one of the most important things about an isosceles trapezoid is that the diagonals are congruent. And a diagonal in a quadrilateral connects two opposite angles. So if I start at A, what angle is opposite or across from angle A? C. So a diagonal would be connecting A and C. That's a diagonal. That's segment. The other diagonal will be from B to D. Because it's an isosceles trapezoid, those are congruent to each other. So we would say AC is congruent to D. A lot of info. What you need to remember. What you really, really need to remember, if you want to circle or highlight or star, is you need to remember that trapezoids, the bases are parallel. They have at least one pair of parallel sides. It's really important to remember. Okay. It's important to remember that in an isosceles trapezoid, the legs are congruent and the diagonals are congruent. Those are the things you want to take away. The other stuff's good to know. We're not going to focus on that as much in this time, but we're going to really focus on what I just highlighted. Those are the important takeaways from trapezoids. Questions over that? So how this is going to look, types of questions that you are going to be asked. Okay. We are given quadrilateral RSTU and the vertices are written as shown. We're going to determine if this quadrilateral is a trapezoid by showing that one pair of opposite sides are parallel. When we're dealing with a coordinate plane, what do we know about parallel lines on parallel sides? What do we know about their slopes? You know what? Yeah, they're equal. So we just have to show that at least one pair of opposite sides are parallel. That's all we have to do. So what you're going to do is plot your points. First, plot the figure and label. So, draw your quadrilateral. Label your points. That's really important to label. That helps you organize your work. And we just have to show that one pair of opposite sides are parallel to each other. Meaning one pair of opposite sides have the same slope. Well, to help yourself out, look at the figure you just drew. Which two sides look parallel? RS and what? UT, right? They're across from each other. They look like they're parallel. I'm going to check those. And they have the same slope, then we're done. If they don't have the same slope, then we need to check the other sides. Okay? So let's find the slope of RS. How do we find slope in the coordinate plane? What over what? Rise over rise. Just have to count up and over. What is our rise? 3. We want up 3, so it's positive. What's our run? 6. Good. What is 3 over 6 simplify down to? 1/2. You have to simplify your slope. You have to simplify your slope down. If you don't, you're not going to tell if it's the same or not. Simplify those graphs. So then we're going to check UT. Let's find the slope of UT. What's our rise for UT? We went down 6. We went down, so it's going to be what? Negative. Then what's our run? 12, but we went left, so it's going to be what? And what does negative 6 over negative 12 simplify down to? 1/2. Do these have the same slope? Yeah. So we just showed that one set of sides are parallel. So is this a trapezoid? Yeah. We really don't care about the other two. We just need to show that one set is parallel. So your answer, you just say yes. It's a trapezoid. And I like to abbreviate in my answers, so I don't like to write a lot of stuff out. So we say yes. One pair of opposite sides are parallel. You can abbreviate parallel with that symbol. Okay. Your math is backing up your statement. So you showed me that two sides have the same slope. You're backing up your argument by saying, yes, one pair of opposite sides are parallel. By not showing you the math, you're not backing up your argument. Okay? So I have to see the rise over run. I have to see that you counted slope. I have to see what the two sides and their slopes are. And then I have to see your explanation. So to show all your work and explain your reasoning, that's your math. Okay? Your reasoning is just saying yes or no. And then why? Yes, because one pair of opposite sides are parallel. So that's what I need to see for you to get full credit. If RSTU is a trapezoid, which it is, determine if it's isosceles by showing that the legs are congruent. And we said the legs are the two sides that aren't parallel. So what are our two sides that aren't parallel? What is it? ST and RU. So let's find the distance of those. By first glance, do they look congruent? No. That can't be your argument. You can't say, well, no, it's not isosceles because they don't look congruent. Okay? That's a good guess, and that's a good reasoning to make sure you're doing your math right, but you have to show the math to back up your argument. You just can't say, no, they don't look congruent, so it's not isosceles. You have to show through your work that they aren't. Okay? So let's find the distance of RU. How do we find the distance in the coordinate plane? What do we use? Read the theorem. We're all pretty good at using this theorem. What is it? Yeah, the Pythagorean theorem. Both of you, good. Which is a squared plus b squared equals c squared. So you make your right triangle. Side you're trying to find your c. Doesn't matter, make one your a and the other one your b. And plug your a and your b in. When we count, what's the length of our a? What's the length of our a? 8. So we get 8 squared plus, what's the length of our b? 3. And then plug in your calculator, what is 8 squared plus 3 squared? 73? 70. What do we still have left to do? Square root. We don't actually have to square root here. You can if it helps you out. You can also just leave it as radical 73. You don't have to go through that extra step of like plugging it in your calculator. You can leave it as an exact answer. You don't have to worry about specifying the radical. You just leave it as radical 73. So now let's find the distance of ST. So now we're going to make our right triangle. Side you're trying to find is your C. Label that A, label that B. Plug it in the Pythagorean theorem. I'm going to label ST. Still using the Pythagorean theorem. When we count, what's our A? 4. What's our b? 2. Careful. 3. Good. And what's 4 squared plus 3 squared? 4 squared plus 3 squared. What is it? I think it's counted wrong. It's 5. Okay. That's not what we got confused. Good. So our A is 5. Double check the count. That's the biggest thing on this is counting the boxes, because I do the same thing here. I feel a little cross-eyed. So careful counting the boxes and be careful plotting. 34? Does that look better? And then what do we still have left to do? Square roots. Are these legs congruent? No. Radical 73 is not the same as radical 34. In order for them to be the same, they have to be the same exact radical. They're not. So is this an isosceles trapezoid? So your answer would just be no. Legs are not congruent. You can use symbols. And abbreviate. Totally fine with that. And again, your math is backing up the fact that legs are not congruent. You can't just put no legs are not congruent with no math. Alright? Your math has to back up that argument. Questions over that? So that's a trapezoid. One pair of opposite sides are parallel to the isosceles. The legs have to be congruent or the diagonals. Let's see it. If you flip it over, another type of quadrilateral that we are going to talk about a lot is a parallelogram. We're only going to touch on the basics. We'll dive a little bit deeper next week. But we're only going to talk about the basics today. And that basic fact is that a parallelogram is any quadrilateral where both pairs of opposite sides are parallel. So, for example, those sets have to be parallel, and the top and bottom set have to be parallel to each other in order for it to be a parallelogram. Both sets of opposite sides. True or false, a parallelogram is a trapezoid. True. Why is it true? What's the definition of a trapezoid? How many sides? At least one. But does that mean you could have more than one? Yeah, you could have 2, right? Parallelogram has at least 1. So a parallelogram is technically a trapezoid. True or false, a trapezoid is a parallelogram. No, that's false. Why is that false? Trapezoid only has 1. Parallelogram has 2. So, we take a look at example 2. We are given a quadrilateral with those vertices. We want to determine if it's a parallelogram by showing that the opposite sides are parallel to each other. Well, again, how do we know if things are parallel? What do we know about their slopes? They're the same. So you have to show that the opposite sides have the same slope. So go ahead and plot your points. What's a helpful tool to make sure you plot your points correctly? Desmos. We are all human. We all do things incorrectly sometimes, self-included. Plot them into Desmos. Make sure you're plotting them correctly. Label your points too, that's really helpful. You can plot this right into Desmos, and then just use an Excel marker and do all your work on the Desmos screen. It's really fine if you do that. Right? Just show me your work on your paper. So if you find a slope, please write down what the slope is on it. Don't just leave your paper blank and then write your solution. So, pick a side, it doesn't matter which side do we want to start with. AB. So let's find the slope of AB. Let's see what that is. AB slope. So again, use rise over run. What's our rise? 3. What's our run? 4. 3 over 4 doesn't simplify, so we just leave it. We want to see if it's the same as the side opposite. So what side is opposite or across from AB? CD. So let's find the slope of CD next. Because if it's not the same, then we can stop. So save us a little bit of time. So what's the rise for CD? How far did we go down? Went down, so it's what? Negative. What's our run? Went left, so it's what? And what's a negative over a negative? Positive. Are those slopes the same? Yeah. I can keep moving. If they weren't the same, you could stop and say, nope, not parallelogram. Because both sets have to be parallel. Both sets have to have the same slope. So then pick another side. What's our next side we want to find? AB. So the slope of AB. What's our rise? Where down did we go? 3. What's our run? We went down, so it's negative. We went right, so it's positive. So let's find the slope of BC. What's our rise? We went up 3, so it's positive. We went left 2, so it's negative. Positive over a negative is a negative. Are those slopes the same? Yeah. So is this a parallelogram? Yeah. So you would say your answer, your math is backing up your argument. You would say yes. Both sets of opposite sides, I abbreviate opposite, are, you can use again those double lines to say parallel. And again, your math backs up that argument. Don't just say, oh yeah, both sets of opposite sides are parallel with no math. You're not going to get any points for that. Okay? I don't know if you're guessing. I don't know if you just, I don't know what you're thinking. By showing me your math, I can see what you're thinking. Questions over that? The last type of quadrilateral we'll talk about today is a kite. Okay? And it looks exactly what you think a kite would look like. Okay? It's any quadrilateral with exactly 2 pairs of congruent consecutive sides. And consecutive sides just means sides next to each other. So in the diagram, we have a kite because GH and JH are congruent. They're 2 sides that are next to each other. They're congruent. And FG and FJ are congruent. Those are 2 sides next to each other that are congruent. Important properties of kites, the big one that you need to remember, is that the diagonals are perpendicular. The diagonals are perpendicular, meaning what kind of angles do they form? Everybody go and take right in. So here, a diagonal, again, it connects to opposite angles. FH is perpendicular to GJ. Another one that's really good to know, but we're not really going to dive deep in, but it's just good to know. That's exactly 1 pair of opposite angles that are congruent. So here, kind of the angles that are in between the non-congruent sides are the ones that are congruent to each other. Good to know, but we're not going to dive deep into that. And the main one we're going to focus on is that the diagonals are perpendicular and the consecutive sides are congruent. True or false? A kite is a trapezoid. False. Why is it false? Yeah, none of the sides are parallel, so it can't be a trapezoid. None of the sides are. 0 sides are parallel. So therefore, is it a parallelogram? No. None of the sides are parallel. So it can't be a trapezoid. Can't be a parallelogram. So our last example, we have quadrilateral ON. There are ON vertices. We're going to determine if ON is a kite by showing that the diagonals are perpendicular. So go ahead, plot those points. connect. And it should look something like that. And we're done. Label, I think it's really helpful for you to label. Oh. I thought something. No, I didn't. Oh, it's going the wrong order. O, W, E. Points are a little out of order though. Again, the diagonals are connecting opposite angles. So start with an angle. Let's start with N. What angle is across or opposite of N? Oh, so that's going to be a diagonal. How do we show that lines are perpendicular in the coordinate planes? What kind of slopes do they have? Opposite reciprocals. So we have to show whether or not our diagonals have opposite reciprocal slopes. So let's find the slope of NO first. So find it with our rise. Up 8 or 9? 8. Went up 8. What's our run? 8. What is 8 over 8 simplified down to? We went up and right, so they're both positive. What's our other diagonal? WE. So let's find the slope of WE. What is our rise? How far up do we go? 5. What's our run? We went up, so it's positive. What's our run? 5, but we went left, so it's what? Negative. What is 5 over negative 5 simplified down to? 1. Is positive 1, negative 1, are those opposite reciprocals?
Yes.
Yeah. Here's the reason why. When we have a whole number, we'll start with positive 1. We put the whole number over 1. When we find the reciprocal, you flip it. But when we flip 1 over 1, it just stays 1 over 1. Our original is positive, so our new one has to be what? Negative. And that simplifies down to negative 1. Okay? So positive 1 and negative 1 are always opposite reciprocals of each other. So, is this a kite? Yeah, because the diagonals are perpendicular. So where they intersect, you're getting a right angle. You say yes. Diagonals, if you get diagonal, are perpendicular. And your math is fast enough to learn. Questions over that? It's really nice because it's going to tell you what method to use. You just have to know, oh, when it says perpendicular, I'm looking for opposite reciprocal slopes. Oh, when I'm looking for parallel, I'm looking at the same slope. Oh, I'm looking at seeing if things are congruent. I just use the Pythagorean theorem. Okay, so you just have to know how to interpret the method. Here's the practice. There's one tiny thing we need to talk about. I'm going to fill in some blanks in the box of your practice. There's one tiny little typo that I thought I caught, but I didn't. We got to fix that. Let's go ahead and fill in this box together. So, we said when showing that sides are parallel, we are going to find the what of each side or diagonal? The slope, right? By doing what? How do we find slope? Rise over run. Very good. And you're seeing that the slopes are the same. Okay. When showing that sides or diagonals are congruent, you're going to find the distance or the length by using what? Pythagorean theorem. And when showing that sides or diagonals are perpendicular, we're going to find the what? Of each side or diagonal. We're going to find the slope. I think there's someone say. By using what? How do we find slope again? Questions over that. One other thing, problem, what is it? Problem, the first one, problem 2, is misnumbered. It says 2. It should be 1. Problem 2, it should be, sorry. Got wrong. I think it's negative 3, 5. Negative 3, 5. So point I. I should be negative 3, 5 on problem number 2. Not negative. I'll mess everything. Okay. Oh, that makes sense. So I should be negative 3, 5. Questions, let me know. Happy to help.